Kuinda mazvinetsa
Ngwano yePepsi kana takushanda tozouya nemaya anotenga moto.
aiwa moya totaura nyaya yemapepa eni. Yeah, good afternoon.
How are you?
Good afternoon.
Teseta munhu handiti.
Yes, we are all in.
Yeah, so today we wanted to talk mainly about the evaluation of pesticides for registration, and also to look at some health issues concerning the use of pesticides. So basically there are going to be 2 lectures this afternoon. So we will start with the evaluation of the pesticides, how you can evaluate these pesticides, usually using field conditions. Then after that, we will talk about other evaluations concerning registration. So let me start sharing. So the first lecture is on pesticide field evaluation for registration. Now, basically, we need some information from, it could be a herbicide, an insecticide, or any other pesticide. Normally on the technical information data sheets, there should be proposed rates, proposed crops, the any types of pests which are controlled, insect pests, diseases, and weeds, and also the time of application. Here I should just say pesticide. So it should be pesticide technical data sheets. Again, here it should be pesticide. So we need basic information from that pesticide technical data sheet, chemistry of the product, LD50, that is indication of toxicity, then solubility, vapor pressure. These are physical characteristics of the pesticide. Then basic information is usually obtained under glasshouse conditions, and we may want to verify it under field conditions. So basically, we know what the pesticide can do under limited conditions. So we need to have an objective of this evaluation, pesticide evaluation, the objective may be to determine the efficacy of the new pesticide for the control of pests in maize. Then we should have some methodology. How are we going to conduct the tests? We can do bioassays for insect pests and the plant diseases. This could be done under laboratory conditions. Last time we talked about bioassays for insect pests. Now we can then select some sites if we wanted to do field evaluations. Now the sites should have the pests which we want to target, probably a wide spectrum of pests. We should know the soil type. Then the crop is to be grown under the recommended agronomic practices. Now, what sort of treatments do we want to evaluate? Number one, we want the new pesticide at the target rate from the chemical supplier. It could be an insecticide, herbicide, a fungicide, depending on the pest we are targeting. Then there should be the standard pesticide, which we should compare it with the standard practice. Then obviously there should be an untreated control. So these are the three basic treatments which we may want to focus on. But when we are planning big experiments, remember we could be testing various new pesticides, and you can have one field trial. Then the experimental design, the treatments have to be replicated, for example, 4 times using an appropriate design. For example, randomized complete block design. The treatments need to be randomized in each block or replicate. This could be your plot, net plot inside, and the gross plot outside. And these blue areas could be the sampling areas, depending on which pest you are dealing with. Now, data collection, it depends on whether you are evaluating herbicides, you collect weed data, insecticide, you collect data on plant diseases. So let us start with weeds. Now, the weed data which you may be interested in is crop phytotoxicity data and weed control efficacy, which you should record from 1 week after herbicide application. You can also use EWRC, European Weed Control Research Council scores to assess crop phytotoxicity and weed control efficiency. This then is an example of one of the schemes or scoring systems. Now you've got a score which is 1 to 4, which represent excellent weed control, up to good weed control. But if your score becomes 5, it means borderline control. 6, it's an acceptable control. Then you have got 3 categories. 7, it's slight herbicide effect. 8, it's poor control. 9, no effects. These are weed scores. With the crop scores, number 1 to 5, it means you don't have any phytotoxicity being caused by the herbicide. 2, probably slight phytotoxicity, which is acceptable. A score of 6 could mean unacceptable phytotoxicity. Then grades 7 to 9 means serious phytotoxicity. Now you can use quadrats which are 50 by 50 and assemble 3 positions either in a systematic or random assembly. You then determine weed species which are in the quadrat, record them. You can harvest those weeds and later on measure their dry weights. With insect pests, you may also develop crop damage scores, which could be similar to the ones in weeds. You may also count insect pests within the crops, either per leaf or per plant. You also determine crop yields. With the plant diseases, there are also crop disease scores which you can use. You also measure crop yields. Now, for all the 3 aspects, whether you are interested in weeds, insect pests, or plant diseases, detailed crop data is needed. So you may want the date of emergence, plant population, plant height, photographic images of the crop phytotoxicity or crop damage, or it could be disease infection, flowering dates, maturity dates, and the grain yield. Then at the end of the evaluation, whether it's weeds, insect pests, or plant diseases, you need an analysis of variance on the data which has been collected. But remember, in most cases, pest count data needs transformation before analysis of variance is done. In most cases, that is what is done. Now, the treatments which you may be interested in could be as follows, or the questions which you want addressed. Number 1, does the new pesticide control pests better than the standard pesticide? So in this case, you need a treatment comparison of the new pesticide versus the standard pesticide or standard practice. The other question is, does the new pesticide cause phytotoxicity, which is reflected in crop yield? In this case, you want to compare treatment comparison, which is new pesticide versus the control treatment. Control treatment, that is the treatment without the pesticide. Now, the duration of pesticide evaluation in Zimbabwe is normally 3 years or 3 seasons. Once we have data for 3 seasons, we can use it for pesticide registration. Now, what you submit to the pesticide registrar after collecting the data on herbicides, insecticides, or fungicides is you need toxicological data, experimental reports which cover a period of 3 years of data collection. This should be data on pest control efficacy and the crop phytotoxicity. The registrar will need all this information. You also need to supply proposed registration label showing how the pesticide is supposed to be used. Dosages, crops, and pest controlled. So this is the information which is then used by the pesticide registrar to consider the registration of the new pesticide. So I will stop here. So what I was trying to illustrate is that if we get a new pesticide, it needs evaluation. In other words, we need to do field experiments. And these field experiments have to be done for at least 3 seasons or 3 years in Zimbabwe. Once we have data for that pesticide, you can then register it for use in this country. Any questions on how to evaluate a new pesticide?
None from me, Doc.
Okay. Let me just stop recording this.